Sorry about that. So, class 2 lever. Got it? If you don't, rewind. Class 3. Class 3 lever, the effort is between the fulcrum and the resistance. If I draw this out, lever, efforts between the fulcrum and the resistance. So fulcrum, resistance, then the effort would be here. So how does this work? Well, if you imagine a pair of tweezers, right? And as you squeeze these tweezers, your effort is here. Well, the point that this lever is pivoting about is the fulcrum, which is right here. And the resistance is the thing that you're trying to grab with the tweezers. So, efforts between the fulcrum and the resistance. Tweezers, resistance, effort, fulcrum. But that's the example. So tweezers, or say a hammer. If you're swinging a hammer, here's an interesting thing. So if you're like swinging a hammer, so if you've got a hammer, and you're swinging the hammer to hit the nail on the head, right? So you think of the hammer and your hand's on it here, propelling it, right? So your hand, where you're holding it, it's the effort, correct? And the resistance is here, where you're smashing it into something. But it's like, hey, wait a minute, where's the fulcrum? Because your hand is holding it here at the end. Well, you have to imagine this thing being extended back to the point where if the line was drawn, the point at which the line ends here and rotates. So the extended line of the hammer to here would be where the fulcrum would be. So a hammer is a class 3 lever. It's hard to imagine that because, again, you got to imagine this extended line from, I'm hitting something like this. So the extended, if I'm hitting it exactly like this, the extended line comes down to where the rotation is, where it would basically be at my elbow. There's the fulcrum as I'm smashing Brenner, which is the resistance, with the hammer. But the effort's right here on the hammer. Those are class 3 levers. So an example is a hammer or a set of tweezers where the effort is between the fulcrum and the resistance. Those are your 3 types of levers. You have a class 1, you have a class 2, and a class 3. You will need to be able to identify all 3 of those. Got it? If you don't, rewind. Next type of simple machine is called a wheel and axle. And if you just like it sounds, a wheel attached to an axle. So that the parts rotate together in which a force is transferred from one to the other small force at the outside of the wheel is amplified to move large loads attached to the axle. So imagine a wheel, the outside of a big circle, and then the axle's here in the middle. So this is looking at it from the end view. And a side view would look something like this. So you have the wheel and the axle. Now, like, how is this a simple machine? So a force, like say if you're turning, say, a large wheel, steering wheel in a car, right? You don't get to do this much, but if you can take the steering wheel off the car and you try just turning that little shaft by hand, it's really hard. But if you turn the steering wheel in a car, it's not so hard. That's the same thing. So the force applied out here is multiplied to the force that's applied, here. So as this thing spins this way, the axle spins as well. So you're applying a force moving this thing. Imagine you're trying to lift up a bucket out of a well, and so you spin this wheel that's got the rope wraps around the axle here. There's a rope, and so as you spin it, it winds the rope around the axle and brings the bucket of water out of the well. Well, I mean, you could just pull the rope up, right? But that's actually kind of hard if the bucket's full of water. I mean, that bucket could be pretty big, have 20 or 30 pounds of water, and you have to move it 70 or 80 feet up, which by the time you got it up there, you'd be sweating if you're just dragging this thing. So you do this, and it has a lot less effort. Now, you actually have to spin the wheel more times because, again, you're moving something through this distance, the large distance, and this thing's only moving a little, a much smaller distance, but it reduces the amount of force needed to bring up the bucket. You just have to do a little, you just do less work for a longer period of time to get it up. But that's a wheel and axle. Now, of course, you guys are all thinking wheel and axle, isn't that for like a car? And the car reverses the entire, thing. It powers the axle, which makes the wheel go, but at that point, it's not a simple machine. But the simple machine chunk of it is that we're applying a much smaller force out here at the edge of this wheel to do something like lift the bucket out of the well. Again, you remember, these machines were, invented a long time ago, prior to, things that we do today. Got it? If you don't, rewind. That's a wheel and axle. Next type of simple machine is a pulley. Most of you have heard of a pulley. Now, pulley is a special type. It's a type of wheel axle that's designed support movement and change of direction of a cable or belt. Cable, think rope, or belt. When we say belt, it's not the belt around your waist, but like a timing belt or a fan belt in a car. Pulleys can be used in systems of multiple examples. So typically a pulley, if you think of a pulley, it's just a round thing in a hanger. You're pulling down the rope this way, and the rope, you're lifting something like that. So it allows you to change the direction of the force. So I pull down, it pulls up. But again, when you have one pulley like this, all you're doing is changing the direction of the force. The force remains, this force is equal to this force. That's a single pulley. Now, where the pulley becomes truly a work reducer is when you start using multiple pulleys together. So when we use multiple pulleys together, it's called a block and tackle. Now, block and tackle, this phrase here, block and tackle, comes from old days. Dates back many, to the sailing ship days, effectively. And they used block and tackle to move things on the sailing ship, such as raise the sails and that kind of thing. So what you end up seeing is that instead of this attaching down here to a thing, there's another pulley that's attached to the object you're moving, and the rope would stretch around this one, around this pulley, and then come back up, and there would be a hanger here like that. It'd fix to that point. So now when you pull on this, it wraps around here, and so this is two pulleys. So basically, this force that moves this, you're doubling your force, but you got to pull the rope twice as far. Now, depending on how many wheels each pulley has, gives it its name. Let's see. Gives the system so you start putting multiple pulleys here. And when I say multiple pulleys, you're talking about something that's like these are all on the same axle. That's a wheel, that's a wheel. That's a wheel. You could have 3 up there and 3 down here. I mean, it depends. When we go into efficiency and force and the power in the next couple of days, we'll give you the names of those different types. But just for today, a pulley is a type of wheel and axle that's designed to support movement and change of direction of a cable or belt. When we talk about multiple pulleys or block and tackle, and each one has a specific name. One's called a gun tackle. I mean, it goes on from there depending on how many pulleys you have. But we'll hit that in a later date. So if you've got this, great. If you don't, hit rewind and watch it again. The next thing we're going into is the inclined plane. AKA the ramp. So, inclined plane. Seen this, it's a flat supporting surface. Tilted at an angle. So again, flat supporting surface tilted at an angle. We'll go ahead and give it some support here. So you're trying to move an object from this level to this level. You put a board down between the two, and then you push the object up the board. It's a lot easier than lifting the object that same distance and putting it into the thing. So especially when you have an object that you literally can't lift, you could probably find enough force to be able to push it up a ramp into the thing. These are used as an aid for raising or lowering a load. Moving, like I said, so moving the object up the inclined plane takes less force than lifting it, but it comes at the cost of the increase of the distance you have to actually move it. So this is the distance you're trying to move the object, right? Between here and here. Well, obviously this distance is longer between here and here, but the force required to do that is a lot less than the force required to just effectively lift it straight up and into the object. If you think about the pyramids of Egypt, they built each one of these things is a huge stone block. They literally built this back in those days by building huge ramps of dirt, and they just kept pushing the rocks up these ramps on rolling logs and setting them in place and setting them in place until they built these massive pyramids, and then they took the dirt ramps away. But that's what they used, was just these big inclined planes, at the point where they built these huge pyramids back in the day with something just as simple as an axle, for the rock to roll on, and an inclined plane to push it up and or pull it. Got it? If not, rewind. Now, next thing is a wedge. A triangular tool which is essentially two inclined planes back to back. Used to separate objects. Separate two objects or portions of a single object. Lift it up. Or hold it in place. A wedge, a door stopper. You guys have seen the door stoppers at school we used to prop the doors open, that little rubber thing we shove under the door. That's a wedge. You think about if you're trying to split a log, and you're trying to drive this little handheld thing, and you hit with the big hammer. This thing right here is a wedge. So you smash that thing down, hit it with a hammer, is a wedge. Later, they designed the hammer to be, it's called a maul. It has a angle at the tip like this, or an axe and axes used to chop wood, but a maul is used to split wood. But a maul it's got a big head on it with a big wedge shape right there, and that's what you use to split wood. You can use portable ones that you hold and hit it with a hammer, but those are wedges. So basically, if you think about an inclined plane, looks like this. So if I put two of them back to back, and then put a body on it, there's a wedge. Another simple machine. And we go on to the last one. The last one is a screw. Some people go, well, that's not really a simple machine. It's a combination of simple machines, but some people list it, some people don't, but we're going to go ahead and say, all right, we're going to throw it in the list here for simple machines. But a screw is a mechanism that converts rotational motion to linear motion. Essentially, it is a inclined plane wrapped around an axle. Screws are used in many applications outside of the basic wood screws. So I mean, you think about it. Right? Screw, you turn it, it goes down the wood. So rotational force causes the thing to go in. So rotational force into linear means along in a line, motion down. So that's what we think of as a screw, when you hear the word screw. But a lot of times you have situations where you have, the holder, you have a rod that's actually got threads on it, and then you have an object that rides along this. So as you turn this thing, this little thing, as the threads move, this thing moves back and forth this way. So you take rotational motion of turning it, and it turns it into motion of this carriage that moves something back and forth. They use these a lot in different places and doing different things, because you can put a motor on this, an electric motor, and just turn the motor one way or turn it the other way, and you can move an object remotely up and down. So that's where you'll see this, in a machine versus a screw, which is something we use to attach wood or objects together. So that's your last type of simple machine for today. So we'll go on in the next couple of days talking about how efficient these things are, and again we'll talk about pulleys and talk about the different type of pulleys. And there's actually formulas and some math to do when you determine the efficiency of these things. And then that's what we'll be doing for the next couple of days. All right? Good talking to you guys. We'll see you next time on 7th grade science.